Well, thank you all for coming to attend our workshop today at FinTech DevCon. Today, we're going to be talking about Encrypt to Protect, how to safeguard customer PII in FinTech. But before we jump into the workshop, let's just do a quick round of introductions. My name is Harmony Richman, and I'm a software engineer at Alloy.
Hey, and everyone, I'm Jeremiah Harlan, senior software engineer at Alloy. And just really quickly before we dive into this, just want to let you all know a little bit about Alloy. Let you all know a little bit about Alloy. Did everyone go to the keynote talk this morning? Great talk. Yeah. So from that conversation, from that talk, one of the main focal points was where we need to prevent fraud. That's something that we need to do, and Alloy is a tool that does that. Helps with decisioning platforms. So, for example, you are a bank. Someone comes in, tries to open up a line of credit. That application will go through. The application may go through Alloy to help with decisioning, see if that person is who they say they are, and whatnot. So, just at a high level, we'll stick with that for right now. But diving in. Let's go.
So today we have an exciting agenda for you all. Essentially what we're going to do is we're going to start by talking about PII encryption. What exactly is it and why is it so important to the fintech space? We'll also discuss some tools for encrypting applications, and the tool that we're going to use in today's demo is AWS KMS. We'll also spend a little time talking about the areas of the application and how they should be encrypted, because different parts of the application should be treated differently. And the last step of this workshop, and the largest part of this workshop, is going to be putting you all in the driver's seat and giving you all a chance to actually encrypt a simple application. So the goal is that at the end of this, you all will have a baseline understanding of how to fully encrypt applications and safeguard customer PII. Sound good? Cool. Well, just if I can get a show of hands, how many of you have heard the term PII before? Okay, all right. So we got some familiar folks. But just to break it down really quickly, PII is personally identifiable information or any sensitive data that is related to a person's identity. Some examples of this could be your social security number, your date of birth, your full name, your address, your bank accounts. You know, this is all sensitive data that you wouldn't necessarily want anyone to get their hands on. So Jeremiah, why is PII encryption important?
It's a great question. So PII encryption is very important. One, it raises that standard of protection on that customer's data. The number one thing that we want to do is ensure that we are safely protecting the data that we have. And PII encryption, we're going to talk about it on three levels here today, within application logs, your APIs, and also your databases. Within the application logs, because you console log things in, you may be console logging something that comes back from the database. It's in the logs. APIs, they'll be responsible for the actual encryption and decryption of the data. And then the databases themselves, we don't want to store plain text data anymore. We want to utilize that encrypted and that encrypted data. And so basically by attacking these three areas right here, there's there's a less surface area in the event of a data breach. Someone breaks into the database. Oh my God, they have hashed data. They have nothing, and it feels good. But that's what PII is here. PII encryption is helpful for that. And so as we talk about encrypting data, one of the services that we actually use to encrypt data is AWS KMS. KMS stands for Key Management System. And it's great because one, we use it to create our cryptographic keys. We use them to actually generate data keys, basically, to go ahead and encrypt data. The service is great. As I said, it's a full all-around service. It handles storage of your data keys, management, auditing solutions as well. And there are a lot of things that it does. It comes with a lot of benefits. So out of the box, as I just said, we have those basic, the basic core things, the key generation, management, and safety. But then also with KMS, those plain text data keys, they are never revealed to humans. They are never revealed to us, which is secure. That's what we want. But then on top of that, we have the access controls for those individual data keys themselves, meaning you can customize and say what applications are able to actually access the data keys, what applications can create data keys. And then on top of that, one of the biggest things is the compliance standards of KMS. By utilizing services that already have those compliance standards, you can inherit those and go forward, trying to make sure that you are complying with your applications, whether it may be SOC 2 compliance, if you're in healthcare, HIPAA. So these compliance standards are definitely something that we want to bring into our applications. And so, stated earlier, what parts of the application do we want to encrypt? Database storage. This is where we're taking that plain text data and we're removing it, and now we have hash data and encrypted data being stored instead. The hash data, there's a difference between the hash data and the encrypted data, and we'll get more into that once we get into the actual workshop itself. But then the APIs as well, they're the layer where that plain text data is coming in, and then we go ahead, encrypt it, then save it to the database. And the process going back, it handles the decryption as well. And then the last part, the application logs. As I said, console log something. If someone were to access your system's logs in OpenSearch, for example, they can go ahead and have access to that PII data, and that's what we want to prevent there as well. And so, as just recapping all of this, by adding these levels of encryption, we can go ahead and raise that standard of security for our purposes, and just let our customers know that your data is properly protected.
Awesome. So as I said, the best way to learn is to do. So we want to give you all a chance to actually work with encryption for yourselves. So the rest of this workshop is going to be actually working with and encrypting a simple app. So the code stack for today's workshop, as we mentioned, we'll be using AWS KMS to build an integration with our application to get those data keys. We'll be using MongoDB as our database, Docker to run the container for the environment, and then Node.js and React for the actual app code. For those of you who haven't gotten access to the repo yet, if you can navigate to this link right here. Does anyone have issues getting to this link? Show of hands if I can move to the next slide.
Everyone good?
Everyone good?
Perfect.
Awesome. So I'm going to give a high-level objective for this, and feel free to just look through the README and read along. This information is there, but I just wanted to walk us through it. But essentially, as I mentioned, the goal for today is to add encryption to a simple application that currently uses plain text data and PII. So we're going to break this up into 4 different sections. If any of you all are feeling really ambitious and just want to go for it, do things at your own speed, we won't slow you down. But we will be allotting about 15 to 20 minutes per section, coming back in between each one and walking through each task if you do have questions. The first step is to actually build that integration with AWS KMS. And we will integrate that into the application, add in data storage for the encryption keys, and get all of that set up so that we can actually use that integration. The next task will be to use those encryption keys to encrypt and decrypt data to and from the database. So that'll be updating our APIs to be able to handle encrypted data. The third step is we're going to update our search functionality from fuzzy search to hashed search. So just a quick word on this. Right now, the application currently does support fuzzy searching. But once we have to update the database to no longer have plain text data and we'll have hash data and encrypted data, we need to also update the search functionality so that it can work with hash data. So that'll be the third section. And the very last will be to update the logging in the application. So it will be encrypted, and we'll also create a new endpoint so that you can view the decrypted logs.
Sweet.
I know I threw it a lot at you, but any questions before we actually jump into the fun part of this?
Perfect. That means you all understood everything. Perfect. All right, so we can go ahead and then just navigate over to our GitHub repo and get started. I don't know why this doesn't work. All right. Okay, so first thing, before we actually dive any further, we have a couple of dependencies that we need to install. Docker, MongoDB Compass. We're going to use that as just a UI tool to view the database data. We're using Postman. Some people may use Insomnia, but an API testing tool as well. Is everyone good there? Sweet. Okay, cool. Yeah, so in the README I also have instructions on connecting to the database with MongoDB Compass.
That part's not working for me, connecting to Mongo with those instructions.
Okay.
So I don't know. You got time to look at what I'm doing wrong?
I do. I have an hour and some time. Yeah, so there's also scripts in here to bootstrap the database with user information as well. But then we have these objectives down below to highlight what each step and what we're trying to do in those steps. First, just getting everybody up to date. Want to make sure that everybody is able to get basically connect to their database. So, all right. All right. I didn't turn it off yet. Okay. I'm going to, for those who are having connection issues, I'm going to walk around and just try to help people out. For those who are good, who have connected, let's go ahead and get started with the first exercise. All good? All right. So creating that top level key is what we're doing in our bootstrapping scripts. But then, and we are safe, and then how our application is able to actually be aware of this KMS key, we are using AWS Secrets Manager. And what we're doing with Secrets Manager, pretty much, I can show you there's the actual script. Where did it go? Yeah. So there's a script right here that configures KMS using a local stack. It creates a KMS key, identifying what usage it'll be used for, and then from that response, we're grabbing the key ID, and then we're storing it in Secrets Manager under a new secret. And that's the whole bootstrapping process. Now, the actual the configuration of the application knowing about the KMS key, we have a config loader, and it's described here in this image of how it works. So this config loader, by default, it'll check, you'll say, I want the KMS key ID. The first check will be to check the environment, which is process.env, and then the next check, it will go to Secrets Manager and grab that, see if that key is within the secret, and then if it's not there, it'll default to a base config that we have set here. And so this is the hierarchy of us bootstrapping the application, and then also making it so that the application is aware of that KMS key, and you'll be using this API KMS key ID to actually create your encryption keys. Any questions? Docker still doing Docker? That's what's up. That's what's up. Yeah. All right. Yeah.
So that Docker installed, and now I'm trying to do the connection thing,
Oh man.
and Docker's running. So what am I missing?
We need to start the Docker containers. So there is a step.
It says, I have no containers running, so what container do I need to use? Is there one?
So there's a command to create them. So can you, in your terminal, did you clone the repo?
No, I did not.
Yep,
I
so
just
let's,
thought of that.
cool, yep. Let's fork the repo, and then once we do that, once we have it locally, then we can start our resources, start the Docker containers. In the meantime, has anyone actually used KMS? Does anyone use KMS today, currently? How do you all like it?
We use Google's version, which I think is the exact same thing. But,
Yeah. So GCP all the way for everything. Nice. How is it compared to AWS?
never used AWS to compare, so
Wow.
Probably straightforward and easy one. GCP's got a better pricing model.
Yeah, I was gonna say, I haven't used it for like the actual implementation to know, but we've done a lot of research on the pricing standpoint. It looked like the pricing of GCP was like vastly different.
Nice. That's what's up.
Different in a good way, or different, better for GCP, but then I haven't used it, so I don't know if there's something here that's missing, but it didn't look like it. They look like they actually have a whole tutorial for using their management system for payment providers. Like that's their tutorial for GCP, but that's as far as I got. Say it again, like, yeah, it's
AWS.
Has Docker finished for anyone?
Somewhere in the middle.
Somewhere in the middle.
Okay.
All right. Let's we can also we'll go through the breakdown of these exercises a little bit further. So with the first exercise, our objective is to set up the encryption keys, and that's a couple of steps in this process. AWS KMS, they actually outline some documentation on how to utilize their data keys, and we're replicating that here. And that flow is pretty much to, once you create that data key, what AWS will return you is a encrypted version of that data key. And with that, you have to communicate with AWS again to get the plain text version of that data key. On our end, what we do is in this application, we're going to, once we create that data key, we're going to take the encrypted copy of it and store it into our database. And the reason why we do that is just so that we have a reference. We know that this key is created. But then when we grab it from the database, we go communicate with KMS again to grab that plain text version, and then we're using that plain text version throughout the application. Communicate in this exercise will be the first one, creating that KMS client. That's going to have a couple of functions, generating data key and decrypting the data key. And I have links to the AWS documentation, to the SDK documentation as well here. And then the next step in this exercise will be to create a database collection to store those encryption keys. And then the last step will be generating. We're going to create those data keys that we need for our purposes. One is for PII encryption, and then the other one is for PII hashing. The hash key will be used differently, and we'll go through that. But at the end of this first exercise, what you'll be able to do, you'll be able to open up MongoDB Compass and view that collection that has data keys in it. So that's what the end result of this first exercise will look like. And also for anyone who does get stuck, please, well, once Docker is done, please let us know. And then we also have solutions for every prompt here. So feel free to snoop around. But yeah. So I guess, is anyone using an alternative to Docker? No, we're Dockered in. We're Dockered in, okay. Oh my God.
So what do I need to do?
I'm sorry?
What do I need to do? You guys clone the repo, what's next?
Yeah, clone, we have it locally already. Perfect. Okay, so now that we have it locally, we can do Docker. We need to run a couple. We need to run
Do I do it on this, on that command line, in that repo?
Docker compose.
Did you already have that in the repo? Where is that?
Scroll down.
For those of you who are looking to set up your Docker containers, it's at the bottom of the README, so you can go through and find those scripts there.
That, just copy all this?
What?
Do this one.
Yeah, start with that
Run
first.
it line by line, gotcha. Thank you.
No problem. We gotta spin up the API. I mean the services themselves first. So yeah, I can put it better word. All right. Yep. So we just want that first command right there. All right. Yeah, I also can make my hotspot available for those who want to try to get through it a little faster. All right. My hotspot is available for anyone who wants to jump on. What is it? It's, yeah, Jeremiah's iPhone. The Wi-Fi password is, yes, it is hot. I got one person. Hey, yeah. Okay, Verizon. There's also a front end portion to this app. Our focus isn't the front end really. Our focus isn't the front end, but we just give you all a user interface to look at things through. But you can also definitely use Insomnia.
Or Postman.
Oh, sorry, yes, or Postman, or the terminal, curl.
Show of hands, who's still waiting for Docker to finish spinning up?
Everyone.
Okay, cool.
Sheesh.
The images.
Yeah, the images.
For those who are on the hotspot, is it you switch back? Dang. Hey, all right, all right.
Maybe I'm just stealing.
Yeah, we're sharing bandwidth one at a time. So yours is finished then?
Nope.
Or is it still going?
Still running, but.
Whew.
Alright, I finally got it. I used it on hotspot.
Yeah.
And that's just the pre-step, so.
Back in the day when things were piling.
Like, yeah, we grab lunch now. Yeah, probably till Docker at least. Yeah.
Is anyone encountering any issues or just waiting? Just waiting, cool.
Is it running slow? Like, is it running? Sometimes Docker will like freeze in the middle of that process. Is not okay.
Not frozen,
Cool,
okay.
cool.
You can see the digits change.
Love it.
Yep.
Is that on my side?
I'm sorry.
Looks like it requires some authentication. Is that something on my side I missed a step or something?
Did you enter the?
I've never set up Mongo on this machine before.
Okay, so let's take it a step here. Mind if let's disconnect from it really quickly, and then this is it, right? Was this it? Yeah.
Yeah.
This looks like it. Advanced options, authentication, Mongo.
Cool.
Voila.
How'd you know my password?
You know, I mean, we got Wi-Fi passwords that are easy.
Alright, there we go.
Sweet.
Like I'm in.
Yep. So you can go ahead. You can run that Bootstrap script in the documentation as well. Then, and then that'll automatically just throw in some users for you. And then you can use Insomnia, or you can use the front end. I mean, you can use Postman, Insomnia, whatever, or you can use the front end to view that information. Still moving slow.
Yeah, I started a little bit later than I was, but yeah, it's good. Well done.
I have a question. Like, do you store the PIIs in the database?
Yeah. Hold on, let me grab you a mic.
I can shout. Keep the PIIs encrypted with the KMS key in the database, and for every query, you just decrypt them? Or do you have like a couple of models which ones have PIIs? Because I think decryption for every query might be quite a heavy stuff to do.
Yeah, so not all data needs to be encrypted. So our business logic is definitely identifying. In this example here, we're only working with user data. So we know to encrypt that data. Now, in regards to, are you asking about how do we do it?
Yeah. If you can share.
Secret sauce. So our way of doing that is similar to this process that we have here, really. In regards to the KMS keys themselves and how we store them, we differ a little bit from the solution presented here. I don't think I can go into greater detail about that, but there are some influences in this project come from our internal. Oof. Any other questions? All right.
Question for you.
Yes.
How are you liking it so far?
I am loving it. This is such a wonderful experience. I've gotten to meet a lot of really great people, and it's always nice to be in Austin. You're quite welcome. Thank you.
Ooh. Yeah. Gosh. Okay. So I know Docker's taking a while, and it looks like it's trying to take. Oh, we finished. We got one more that finished. Yay. Another one that finished. Oh.
All right, it's happening.
Any more dominoes? No. Okay.
I got a little bit left, but don't wait for me.
We will wait for you.
I entered the command like 5 minutes after everyone else, so.
Maybe we will like we get it. Now
You guys are off the
finish.
network.
We
Light
will
up.
be so fast.
Yeah.
All right. So let's while things are installing, we can dive into the code a bit. So let's start doing that. So the first thing that we're going to do is create this KMS client, and how that looks. Like I said, there are solutions for everything already. And then we also have, if you want to see how we've implemented the solutions, you can go to pull requests. Look in the pull requests. We have READMEs documenting our approach for everything. So that's actually what we're gonna do. All right. Oops, sorry. That's not good.
Yeah, that hasn't been loading.
Dang, GitHub. Okay. All right. So for the first step, what we're doing here is setting up those encryption keys, as we said. And the way that we went about doing this for this exercise, and everyone can do it differently. You know, it doesn't have to be the same thing, obviously. But first thing, obviously, we need to install a couple of dependencies. I mean, one dependency, which is the KMS client. And now, once we have that set up, we want to establish that connection to KMS. And that's what this code here is about. There's a couple of private functions to set up the connection itself, but ultimately the two functions that we want to create are, let me see if I can make this a little prettier. Yeah, there we go. Sorry, y'all. Oh, this is killing me. Okay. All right. 1 second. Boom. All right. So ultimately, when we create this KMS client, we have two functions that we want to export, really, that we want public. It's generating that data key and also decrypting that encrypted data key. AWS has, as I said, AWS has some pretty good documentation on doing this, and we try to do everything in TypeScript here just to be very strict on the types themselves, knowing what we're doing. So once here's this KMS client, yours can look however, obviously. Once we have this client, we then want to go ahead and utilize this client. So we have, now that we're connected to KMS, we want to be able to actually encrypt and store that data. I mean, I'm sorry, not encrypt and store. We want to be able to store those encryption keys. And so we have this encryption key service here, and what it's responsible for is exactly that. And what it takes is going to take two functions. One is a function to actually store keys in the database, and another one to get keys from the database. And we'll show you where those are being used. But at the bottom of this, we have this exporter function called fetch encryption keys. You pass it those two functions to those two database calls, pretty much, and then also that KMS key that I talked about earlier in the setup. And then there's also this other option to skip AWS KMS. This is we kind of put this here just for like, let's say you're in a test environment that doesn't have access to KMS. If we don't have access to it, we're just returning these default data keys here. Like for example, if you are doing integration tests, or if you're doing integration tests but you can't connect to KMS, this is what this is. However, we are going to connect to KMS. We create this new encryption service, but then we have these we have this function called get or create a wrap key. And when we say wrap key, I just mean that wrap key is the encrypted data key. And so what happens with that call, we go ahead, we try to get that unwrap key first. And this function here, it uses that first database call, fetch the wrap key from the database. If there is no key in the database, then we automatically know that we haven't created this key. But if there is, we call on KMS to decrypt that data key, and then that's the key that we get back that we will be using within our application. And so that's what this is here. And then obviously if we don't have a key, we're going to create that key. And that process to creating the data key is communicate with KMS to create that data key, and then we are going to store it. And just to make sure that this process works, like once we store that data key, we're going to go ahead and fetch it in that same process to make sure that we can decrypt it as well. And that's pretty much that first step, creating data keys, and we're able to store them. But we've just created the functionality for that. We haven't made the updates to the database yet. So that's actually the next step. We're going to create this new, in Mongo they call them collections. So we're going to create a new collection to store those wrap keys. And so I define that collection here. And that's what this looks like. So this is the model. It has a title. Title is whatever you want to call the key. The wrap key itself, and the wrap key ID. The wrap key ID is the KMS key, the master KMS key ID. And then I just have some types down here. I'm sorry, this is the actual repository for interacting with Mongo. So these are those functions that the encryption key service uses to communicate with the database. They come from here. So create wrapped encryption key, just create a new record and save it. That's it. And then the last step is actually implementing this entire flow. And how do we do that? Well, we have that function fetch encryption keys, which is basically doing all of that magic for us. And we also need those database calls. And so we fetch wrapped encryption keys, pass in those two database calls, like I said, and then also the config value for that KMS key ID, and then also the option of if you want to skip loading from KMS or not. And then another step that we're doing here is just adding it to our route so that they can be used. I'm sorry, adding it to our HTTP. To our HTTP library here. We're using Happy in this application here. So we just want to add it to our Happy app so that we can use it later in our controllers and whatnot. And how that looks is just here. On every request, I set these encryption keys, and that will be the first exercise. So now when you're done, what does that look like? So if we check out into this branch, and all right, we have local stack of Mongo running. And so now let's also start the API. You can always look at the logs. I use in the application, we're using a module called Bunyan for our logger. And so I like it because it can help you print logs. But I also have some logs here, some simple logs here. Like it'll tell you what things it's pulling from the environment. For example, when I was going over that config loader earlier, it'll say like, hey, I pulled this this key from the actual environment, the app token. I defaulted to what we have, Mongo URIs in the environment. But then when you get to the KMS key ID, you can see that we got it from Secrets Manager. But this, once again, at the end of the exercise, we can know that things look good. Refresh, pop open, and we have 2 data keys right here. I'm sorry, that may be kind of small, but in our application, we're saying we need 2 data keys, one for PII encryption and other one for PII hashing. You can see by the titles. So, all right, so now that we've gone through a walkthrough of the first exercise, has Docker completed? No?
Yes, yes. Okay.
Yes.
Anyone still waiting?
I'm doing the API front end now,
Ooh, okay.
Love it. Okay, perfect.
so that's the next thing, right?
Yep, that is the next thing, yes. So we can actually, I want to let you all try to code this out as well. But if you all want to look at just the solutions themselves, by all means, feel free. But has anyone started actually diving into the code, trying to communicate, trying to set up the KMS wrapper? How's that going for everyone?
I'm getting builders
Oh no.
for packages not existing and such.
Which branch are you? Did you build?
Just to test, I pulled full solution, and I'm getting errors about AWS SDK not.
Yes. So in the main branch, we don't have all the dependencies installed, but in the full solution, there are more dependencies that are installed. So I would hate to say this, but you have to rebuild that image.
I can do that.
Yeah. But yeah, anyone else? Yeah. I would say, actually, yeah, probably should have. If I would have known Docker was going to be like this, I would have said, let's check out into the full solution and then do then build all the containers, simply for that. But anyways, while we're here, anybody have any questions on encryption key setup?
Why do you keep the encryption keys inside of a collection database instead of using like Secret Manager or something else? It's more like infra based and can be automated via Terraform, something like that?
It's a good question. I don't think I have an exact reason why Secrets Manager over. Actually, I don't look at this encryption key as a this wrapped encryption key, the encrypted version of it, I don't look at it as a secret. With it being in a database, there's no harm because if your database is infiltrated and someone grabs that key, they still can't decrypt any of that data.
They can't go to the KMS.
They will have to go to KMS to get the actual data key. So even with having those data keys and the wrap keys and the encrypted data, it's still no use.
I look at it from like different endpoint of like corruption of the data key. Someone deletes them by mistake because they're in the database. So we need to like have a full system of grant of permissions.
Mm-hmm.
And via like in a secrets manager, you can just read only key, you cannot delete it, and then it's much more like engineeringly safe.
Yeah. I would hope no one accidentally goes into the one database table that you shouldn't manually edit and delete keys. If that were to happen, I would say, we would probably roll back. We do. We definitely back up our databases daily. So we would just do a rollback to grab that data.
Do you shuffle the main KMS key once in a while? Re-encrypt everything?
That's more on our data security team who handle that. And I'm not 100% familiar with the process. I do know that we have to keep these data keys indefinitely. But AWS handles most of that rotation on the top level domain key for us.
Thanks.
No problem.
From a security and compliance standpoint, where do you define who has access to change those keys?
To change the keys, when you say
Or actually, I should say who has access to the keys if you wanted to restrict it.
Yes. So yeah, we use AWS IAM roles for all of our resources. So everything is like strictly locked down. At no point can I just write a script to generate data keys using our AWS environment. I'll definitely get denied, but then also within our system we have it so any interaction with AWS that's unauthorized or you don't have access, an alert actually goes out. And so we then do backtrack, see, where did this come from? But we definitely lock it down on a very granular level. Any other questions on that? All right. Has anyone been able to code yet? All right then. With that, let's go ahead and let's move to the second exercise. Which is encryption API usage. So from the previous exercise, as we stated, we want to get those keys set up, and now that we have them set up and they're exposed to our application, we can't, none of the images are working now. Now that we have them, these encryption keys, we can now go ahead and use them in our application. Now, I do want to make a disclaimer here. There are a couple of steps that are not done in this application that will be done normally. Once you create these new columns for the encrypted data, once you create new columns for the encrypted data, you definitely want to backfill previous data. That's a crucial step that we definitely want to do. So I'm just noting that here. It's not done in this; it's just a small demo. But in real world application, you definitely want to backfill that data before moving forward. And so we tried to outline what those steps were for utilizing these API keys. Utilizing these encryption keys. So have them by commit. The first step that we do here, we're just going to update our user collection to store these PII fields. And we only have a couple of PII elements in here. So date of birth, email address. And for each one, we're going to store a hashed and an encrypted version, encrypted copy. And this is just updating types, TypeScript. No need to really go through that. But once we have that first step done of updating that user model, that user collection, now the next step would actually be to set up your encryption library itself. We have the encryption keys, and we want to store that data, but we don't have a way to encrypt or decrypt that data yet. And so the next step is actually creating that. So I have this little helper here that encrypts data, decrypts it, and then also hashes the data. Also can hash data as well. I have some links to some to solutions on encryption and decryption on ways to implement. You could do it through a variety of ways, but this is encryption and decryption right here and hashing. So once we have this little library to actually transform that data, then the last thing that we can now do is transform the data. So that's when we come into our controller, and I abstracted some of these functions out. So when we have a user that comes in, we want to format that payload to basically the user model that we had before. This is where all that encryption and decryption is happening. So in the format new user comes in, we encrypt and hash that data, and then we save it. Also have this other function for decrypting a user. Let me just jump down right here. Yeah. So this new process is now encrypt the user data that comes in, store that user data, and the database is only going to return the encrypted columns. It's no longer going to return those plain text columns, and that's the point of where earlier we were talking about that backfill. If you haven't completed that backfill, then your code is going to error out. So the database is going to return that encrypted user. We then decrypt that user using our encryption keys, using that PII encryption key, and then return that user. So that's the functionality. But then everywhere else throughout the controller, there are updates were made to basically decrypt all the information coming back from the database. So that's what majority of these changes are. So before it was just find those users and return them. But now find those users, decrypt them, and then return them. And so that pattern is followed all throughout here. And then the other place that we make updates will be to the user repository itself, to just update what fields are we returning. Before, we used to return these fields, the plain text column fields. But now we've updated it to just return the encrypted fields only. And that's pretty much it. So now your API at the end of this, now when you are calling on data, you can actually go into your database. I don't know if I have any data in here. I don't. But this is where that Bootstrap script comes in. I could just create some data real quick. And then we come back to the database. Look at that. That's pretty small. You can't see it. But I still have the plain text columns on here because the actual process of PII encryption is there's a lot more than just these steps. Once you actually are saving and utilizing that encrypted and hashed data, you then want to go back and remove these plain text columns because it's still exposed in the database, obviously. But this is what it'll look like. You'll see date of birth encrypted. If someone gets into your database, this is what they'll see. And that is so not useful to them, but so great for you.
So with the hash values there, especially for like socials, right? There's only 9 digits in a social. It would be too terrible to generate a rainbow table for every social and what the hash looks like. What's preventing somebody from using that hash in order to essentially reverse engineer with the rainbow table?
It's a good question. So there's a difference between hashing and encrypting. Hashing, you can reverse it. I'm sorry, encrypting, you can, encryption, you can reverse it. Hashing is just one way. They would also need, when we hash the data, we are utilizing a different key, and our strategy is different. So you can have that table, you can have that, but you can tell that these two values are the same, so you know that they are probably the same social. However, you still don't know what the social is. There will be no way to reverse it still. So you need our encryption key for that. You need the encryption key for that, and you need to know exactly how we hashed.
That's it's just like a brute force. I mean, so if you've got the key and you would have to make the table based on the key that they use
Right,
to hash it.
right.
You would probably find that in the wild for a rainbow table for that.
Right, I didn't realize that you guys were essentially solving it with the security key as well.
Mhm.
I missed that part.
Yeah. So yeah, this hash function, it takes it in a different key for that. Yeah. And
Okay, so yeah, you have to have access to something.
yeah. And then you would have to know that this, as I said, this is common. You can Google this. This is easily Googleable. However, yeah, you need our information. You need that key. But also, to go back to the point of, if you go into the database and someone grabs the PI hash, the wrapped version of the PI hash key, you still can't do anything with it.
So, like, in practice, when using data like this, I mean, some fields like last name, I mean, technically, the personally identifying information is kind of like scope. I mean, if you go from like the world of PCI, it's like credit card number and like protect that.
Mm-hmm.
And then over the last few years, you know, it just basically just encrypt everything, right? But then, like, from a business purpose use, I mean, if you have to search over customer records and you have some application where you're like, hey, look up customer by last name, you know, what are your strategies for searching over that data if it's been hashed? Basically, if I'm understanding correctly, they would have to type the customer's last name in exactly.
Yes.
Even case sensitive, in order to locate that record.
Mm-hmm.
Or you can't search by that field.
Right. So I'm sorry, ask it one more time.
Just, I mean, strategy, like, some stuff that you don't need to necessarily search over, like the full social security number or anything like that. So just encrypt it, hash it, whatever, it's fine. But sometimes just for like a business purpose, like you have some merchant, they did some transaction, they need to pull up that transaction record. The customer calls them and says, what's your last name? They say Smith. So they do a search on Smith, but in order to find the records associated with Smith, like, you either have to have a plain text search to search for the word Smith, and so you can't encrypt it. I guess my just question is like, what is the strategy for dealing with PII type data? You like to encrypt, but you still need to search over.
That's a great question, and that actually leads us to the next exercise, which is search. We want to update our search functionality. Harmony talked earlier about how the search functionality that's implemented in the app today is fuzzy searching. So you can search Jim,
Yeah.
and it'll also return you Jim, Jimmy.
Yeah.
And that's what the current search functionality does today. But that's when you have plain text, you're able to do that. But now moving towards updating the search functionality, that's when we actually start using those hash columns. So when we were searching, and I actually have an outline. Oh man, it doesn't work. Sorry, y'all. But yeah, this process, yeah, it was this diagram that GitHub is not showing. But basically, in this process, we are actually converting those search filters to search on hash data. So you have to be exact. So when they say I'm looking for Smith, yeah, we're only going to pull you records for Smith. But if you enter more indicators saying this I want it to be this first name and this last name, you'll get closer matches, obviously. But yeah, we utilize that hash data to search on instead of the plain text data.
And I think if I'm understanding your question, I think the point is just you lose a little bit of the flexibility, but you add security to it. So there are trade-offs here. But like you mentioned, you don't have to encrypt every single field. So there could be potentially other methods of searching or other columns to search on that could still give you that information that wouldn't require an exact hashed match. Yeah. Cool. So we'll move on to the third task, which, thank you for that great segue, is on PII search. So now at this point, we have the encrypted and hashed columns inside of our database. We've updated our APIs to be able to encrypt and decrypt that data coming to and from. And this next step is to update the PII search so that in the search functionality, you're not searching on any plain text data. So there are a few different steps that we want to go through, but essentially what we're doing is we are updating the controller to handle that conversion from plain text to a hashed value. So I know we went over this a couple times, so I'll just say it again quickly, just so we're all reminded. Hashing is a one-way conversion. You cannot unhash something, whereas with encryption and decryption, you can. So if we walk through the different steps, we're going to update the controller to convert that plain text search data into the hashed search data. And we're also going to update the actual searching so that it's understanding what columns it should search on. The actual returning of data from the database is the same flow. So we send plain text to the controller hashes the data, it searches the database for those hashed values, returns the encrypted data, decrypts it, and sends that back to the client. So really, it's just we're changing how the controller accepts that data and sends it to the database. So if we go ahead and take a look, here we are in the user controller. And the biggest change is that we're going to create a new functionality here. And in this case, it's called hash search filters. And what that means is we want to take the different filters that are passed through. And the first thing we want to do is we want to check what the filters are. So obviously with a bigger application in production, you can have a lot of different columns to search on. But in ours, for the sake of PII, we just have a bunch of PII columns: first name, last name, email, phone number, date of birth, and then a user ID. If we're searching on, or the user token, if we're searching on user token, we don't have to hash that because there's no sensitive data there. So that's just an example if you were to be searching on non-sensitive data. So here in this function, essentially what we're doing is we're updating the search parameters. So instead of looking for first name is equal to John, we're looking for first name hashed is equal to the hashed interpretation of John using that hash key. So that's all this functionality is doing here. And then in our actual code where we are searching on users, instead of just passing those filters all the way through, we're going to call that function we just created to update those filter parameters, and then instead search on that new query. And then all we did here down in the user repository is we just removed the previous fuzzy search. Since we're no longer using that, we can just pass the filters that's coming in line, this line right here. We're just going to actually pass in the filters, call the function, and then pass those filters through to get back the required data. Any questions on this?
So would this still work? To his example, if you're looking for capital Jim, but you search for a lowercase Jim, would it work?
It will not work. No, so hashing is case sensitive, and that is an important thing. So just one thing to be aware of when you do move to this, that will create some sort of like boundaries, but the trade-off is that it's more secure.
Yep. Would it make sense to hash, have another column of a hash of their name in like lowercase, and then your searching could then you could match in that way it could be case sensitive.
I would say for you, that would depend on if you want to keep that functionality, but then how many you may be storing a lot of different alternatives.
Right.
You know, so Jim also is Jimmy.
Right.
That may be James. You know? It's a lot of nicknames for stuff. So
But also, like, I could envision like a slightly different strategy where, depending on how you store the information, like if you have the two-way encryption, it stores it exactly as the customer has it, like capital Jim. But for hash, like one-way searching, if you also store the hash, you might just slam everything lowercase, and so that way, when they type in the search box, Jim, you translate their search into lowercase Jim.
And then hash on that.
Look for the hash there, and you'll know that you should land on that or something. That it just seems like the gist of this always comes down to trade-offs.
Yes.
Trade-offs, and then like the complexity, you know, because if you have to store more, then it's, so one thing might be to like look at the fields that you have and really question, like, are we prepared to live with the risk if this wound up on the internet? You know, and some are clearly no, like social security numbers, and then last names is not great, but it depends. I mean, if you're selling pet food and Smith bought pet food, okay, I mean, it's not great, but it's not the end of the world. But then if it's a medical provider and Smith went to get cancer treatment, maybe you don't want that to be known.
Yeah, I'm not that familiar with PII as far as like regulation around that stuff. Do they have like, I'm more like PCI stuff. I can go like, you can't store credit card numbers unencrypted, you know, they frown on that. But in the PII world, do they frown on storing last names? I mean, like, is that kind of a standard, or is it sort of a suggested thing to think about? That's kind of,
HIPAA probably
Yeah.
kicks in there as the main one, but I think there's very few actual PII regulations. Like, it's more about just protecting the right stuff and doing it right by the users and protecting your data in case of a breach.
Yeah.
I think in Europe, GDPR may have certain requirements on what's encrypted, but
Kind of go the other direction. Like I'd probably have a different take on that. So like if you go to California, they have like CCPA and it's like CRPA. They have like another version of it. And for my squid test, it just looks like, you know, PCI, credit card number, bad, don't do it, right? It kind of feels like that's what the CCPA is, except for every field of information that you have. You're going to have a different regulating body, i.e. in this case, the California state government. If they decide to fine you, because PII is defined as things like eye color, hair, ideal things, like no joke, like my driver's license, that's a piece of identifiable information. If it leaks, it wasn't disclosed to the customer that you have it, then they could just be like number of records times this. There's not a lot of lawsuits yet that have occurred that have demonstrated like you know, like a basis to know, or like PCI at one point was like $100 a card, and that was just, that's the known fee. But the regulations and laws are starting to go, basically encrypt all the things, which is why their example
More strict.
everything encrypted to some extent. But I would look at if you can find a table that lists PII for CCPA, that might give you a better understanding of like I get it. PCI is credit card number, but what is all these other PII fields? Like, what are they frowning upon? What do they not want you storing? So if you were to probably Google that, like CCPA and you know, for a table they have, it's by letter, it's A, B, C, D, E, F, G, H, I. Like there's like 12 categories of different types of data that they frown on, and then what's the punishment per category? Like I don't know. So.
I would, to add to that, I would. Your company can define what PII is as well. So for us, we can't just say last name is PII. We can't just declare that. Like we have to go through actual, like in fintech, we have to go through our process with legal, and they have to say yes or no. This is under that category.
A lot of times it's a combination too. So like what happens is that legal filter that you're talking about, what I've seen is like they'll reference it says the name by itself, maybe not, but if there's an account number next to it or an ID that could be used to identify who that person is, then yes, now it is. And those two pieces of data together puts you in the crosshairs.
Yeah. So Like, of course, you never want your social
Sure.
out there, but someone they need your name in order to use a social as well. Like, so it's a combination of various PI elements.
Right. Yeah, you might even question, I mean, if you needed to search by social security number, like, we probably shouldn't be doing that. We probably shouldn't, making that a feature, right? But searching by someone's last name, like, that's a common use case that.
The irony of it is that a lot of these government bodies that are making these regulations, that they have databases from back in the 70s that are doing all these things they're telling us not to do.
Mhm.
But anyways, best practice moving forward is to be thoughtful in the approaches like their demo is showing.
Yeah.
Yeah.
Sure.
Yeah. And one big thing to note, all of these changes since all of these changes are on the API side, one thing that we always want to make sure is that we're still reverse compatible. So our request bodies don't change at all. So from the end user perspective, while we're doing all of this, they really don't know what's happening. They just know that it works. So throughout the entire time, all of these routes, if you opened up Postman, you will have access to these routes. Pretty simple: get, create, search, and decrypt app logs, which we're going to get into next. But as we were talking about, like those searching previously before, this is not going to yield you any results if the person's name is Jonathan. But then also with PI, so like we're also saying this has to be a combination. So the first name on the record also has to have the same email address that we're searching for as well. So it's not saying give me all the users with this email and give me all the users with this first name. It's saying give me all the users that have this name and this email in combination. Yeah. Any other questions on that? Sweet. All right.
Cool. Well, we can go ahead and jump into the last task. And if you all remember, thank you so much. The last task will be actually encrypting our application logs. And just as a point for this, in this demo today, everything that we're going to be doing with our application logs will be viewable through Postman or Insomnia. If you wanted to, you could build out a user interface just to make it easier for folks who want to view decrypted logs. But just for our purposes today, we'll be viewing everything directly in Postman. So, as this is saying, we log PII in when we are logging request and response data. So when we're sending data to and from the database, whenever things are interacting with each other, there could be potential PII moving through that. And so what we chose to do in this demo today is just encrypt the entire response and request headers and bodies. Sometimes we can have sensitive data on our headers, so we want to make sure that that is fully encrypted, and then obviously in the bodies as well, where we could have PII floating through. Again, as we've sort of talked about today, every company, every product can sort of make their own decisions when deciding what to encrypt, but for our purposes, to just make something very, very secure, what we're going to show you all is how to fully encrypt API requests and responses.
So yeah, just want to know, if you've been playing around within your logs, you can see when a new request comes in, it has the headers.
Just a quick hint, can you move it this way on the screen there?
Man, thank you. I can make it bigger too. Okay. All right. So in your headers, that's where authentication is happening. You'll get your auth tokens in your headers, whether they'll be within the incoming request or the response. So, that's sensitive information there. And the request body, clearly sensitive information here. And then in the response, let's say we do find a record. Let me find a record, for example. What's up, Lacey? I'm going to use Lacey. Oh no. Oh, I see what's up.
Yeah.
Whew. Live demos. Yeah, and as you can see, here's the response. It returns this information, but when we look in the logs, you can see that information that was returned. So that's just a note.
Awesome. Yeah, so essentially what we're going to do is we're going to create a new encryption key specifically for logging. So we'll have the encryption keys, the hashing keys, and now the application log encryption key as well. And the point of that is really just to have added security, to have two separate keys for the rest of the application versus the logs themselves. We'll also create a new route to decrypt that data. And as I mentioned before, you can see it in, you can build a UI for it, but for today, we're just going to be looking at it in Postman. Do you want to talk about the request cycle?
Yeah. So, are people familiar with the Happy framework? Similar to Express, it's an HTTP framework, and it has a request cycle. Every one of those HTTP libraries has a request cycle, and so on request, there are a couple of events that we're utilizing for us to actually log information. So on request is basically when the request is news coming in. That's when we're initializing a couple of things. But then the next interaction, so I'm sorry, on request is like when we're attaching the logger to the request itself. On pre-handler is where like we actually log what is in the request, the headers, the body. And then on post response, that's right before we send the response back out after the controller has done its logic. But before we actually send the response back out, that's when we log what information we're going to be sending back. So with that request, so understanding that request cycle, we understand like where we're actually logging. So going into the actual work, when we want to create a new encryption key, this is pretty much it. In regards, what we're doing here, we just we have once again we're updating these types so that our types can know how many keys there are. So when we're using it in our app, we can easily encryption keys.app logs. IntelliSense is helpful on that. But pretty much this is it. To add a new encryption key, we want to make a default one just in case we're not using KMS. But then we just call a new. We call this call again before a new encryption key, and we're calling it app logs key, and then we're returning it. That's all it is. This is saving it in the database for us. This is handling all of that. And let me actually do this. I'm here already. So that's the first step. And then the next step, once we have that key, we want to start using that key. So we want to encrypt the request and response, the request and response. So here's what we're talking about on pre-handler. This is before we get to the controller. We're logging that request information. As you can see, this is what it was before, but now we're changing it. We want to encrypt those headers, and if there is a body, we want to go ahead and encrypt that as well. And then on post response, same thing here. Forgive the TS ignores, but same thing here. And remember, we're utilizing the app logs encryption key specifically. So if someone does get access to the worst case, the plain text version of this key, they can only use it for the logs, which is still, you don't want that obviously, but it's another surface area that's protected, isolated from other things. And yep, once we encrypt that data, the next thing that we want to do, now that this data is encrypted, we want to be able to actually view the data. Let's say you have you're debugging, and you want to see what information we sent back. Here's a route. We have a route to do that, and it just accepts a simple body, encrypted text. Actually, I can show it to you like this. That ain't right. Okay, I'm gonna show it to you all differently. So basically, get that encrypted text from the request body, and then we have this wrapped in a try catch, just because if someone sends malformed text or text that we can't decrypt, this function will throw. So we just want to capture that error and handle it properly. But we take that text and we decrypt it. And one thing to note, before we encrypted that information, we did a JSON stringify, just because in order for us to encrypt and hash data, it has to be a string. So yeah, decrypt that data and then simply just return it. Any questions on that? No questions? Great, great. Okay. Let me try to get this up and running for us then. All right, so let's go ahead and search one more time. Boom, and this is what it looked like. What is this header string? I have no clue, so we must decrypt it. So we're gonna come over here. Actually,
It's in the. It was in the PR.
Decrypt logs. Takes a body. JSON, and from here, encrypted text is the key, and the value is this encrypted data. Let's go ahead and decrypt that. Oh, supposed, sorry. And there we go. And you have your response for those headers. You can do the same thing with the request body as well. I mean, request to response body. I don't feel like I'm copying the right thing. Oh, sorry. Okay. So one thing that you can get lost in with this, as you can see, I was trying to put the body back, like take that encrypted text and decrypt it. However, it can get really, really confusing because I'm decrypting this text, which comes from this route. So the body is going to be the headers in plain text. So you gotta make sure that you know what you're decrypting. So like here's the route that I'm looking for, and here is the actual response body right here. And boom, there we go. You can actually see the response. Any questions?
Just wondering how granular you get with your keys. You know, do you do it like per specific field? Do you just do it as any PII using the same keys as the other PII?
So it's the data keys are owned by services. So each service has its own key to encrypt and hash its own data. Has its own data keys for encryption and hashing. So for example, let's just say this is a microservice that only handles interactions for users. This service is going to be responsible for the keys that we created. We have another service that, I don't know, stores addresses. That will have its own encryption key, but there's a wrapper that you have to talk to the addresses API, let's just call it that, to get that decrypted information. So it's more like service layer for that. Any other questions? Have people played around with the code, looked at the code yet? Feel good?
Anyone still waiting on Docker?
All right.
Well, as Jeremiah mentioned, we do have like all the full solutions, the branches that you all saw. So definitely feel free to go home and play around with it and reach out to us if you have any questions. Yeah.
Back to this logging encryption. This could get, I feel like this could get somewhat expensive API-wise, reaching out to AWS. You have to pretty much decrypt every single request through logs. So for us at our company, we usually look at logs, maybe 10, 20 at a time.
Mm-hmm.
The stuff I'm working on, none of it is actually PII we did just add a field that was PII, so instead of encrypting the whole log, we just completely exclude that field in the logs. But in this case, you're encrypting the entire log. So if you want to do 10 logs, wouldn't you have to call 10 times AWS? Right?
So that's a great question. The operations of if for every request we had to decrypt that encryption key, it would get very expensive. And so what we do in our application on startup, we grab all the encryption keys and we just hold those in memory. We grab all the plain text copies of the key and we hold those in memory and we use those. And so that way we just save on those operation costs.
Okay. You would still have to call out to decrypt though, right? With the specific data.
We're not calling out to AWS to decrypt. The only time we call to AWS to decrypt is for getting the plain text version of the key. But the actual encryption and decryption of our data that we store, this using remember that encryption library that we made that handles encryption hashing? We're using that, and that encryption library is using those data keys. So yeah, here we are. Yeah, so it takes that data to encrypt and then also that encryption key itself. And then it's utilizing it.
I think if it's something in the nuance of what was just described there. So like, I get the point you're making, which is like, yeah, we look at logs all the time. This is going to be expensive. So, but you're saying you're only just putting that.
When we boot up the app, that's the time that we fetch those encryption keys and we store and we hold them in memory.
So like the encryption in like that, thereby the encryption key itself is in memory of the application, or just the encryption key of it, or
The encryption keys are stored once they're fetched from AWS. The encryption keys are stored in memory. Yes.
so like if in this example, if there was 5 log files and some bug that just sucks and you have to go through 5 log files to like try and trace it through, you already have the decryption key, so you would just run the whole log file with the key that you already have in memory, and it would just spit it all out.
In layman terms, yes. Doesn't follow that exact order, but yes.
Do you guys have any other like searching provider type tools like Splunk or something like that, where
We have Splunk at our company, and
like an help stack or something where you need to search over like massive amounts of logs?
normally what we tried to do first was remove any PI from being logged. That's first. So to answer your question, we don't run into that case really because we don't log PII in our logs, and if we do, it's encrypted. So when you're debugging, if you need to see that PI information, then that's when you utilize this decrypt route. However, if you know that the point of the problem isn't in this payload, in this PI object that's being logged, then you're looking, all of your other logs are plain text still. So like in this example, like everything else is still plain text. The URL is plain text, for example. So we're specifically choosing what to encrypt because of the sensitivity.
You can also choose to like redact specific pieces of data as well, so you can keep the log like untouched. So there are different ways depending on what it is you're looking for.
Yeah. And that's something that we definitely do. We so like for some responses or just for some data that's logged. For example, you talk to another fintech provider through the API, and they're sending you back information. You may have some service or whatever that logs that response coming back from that vendor, and that vendor's response is PII, for example. But that's very different from our PII. That may be different from our PII. Like they may have, like for example, we have name first in our application, but they may send and so we can have our key say make sure that whenever we see a key name first, replace the actual value with redacted. But the vendor may send back that PI saying first name. now your logger won't capture that. So in certain places, that's when we're just like encrypt all of that, because we don't know what that response could be. We don't know what it can contain. And so that's how we handle that. So it's like, all right, I need to see what the response was from this vendor. Now you know what more to look at in your, like you can get more granular in your logs rather than just saying I need to look at the full story of this request cycle. You can say I need to see what information came back from that vendor. And now I know that's in this particular log, so I don't have to decrypt all the logs, just this one piece of information.
You can also store additional metadata about what you got, like number of entities returned, stuff like that, to make logging easier without decrypting it every time.
Yep.
Just if you actually see the actual PII, then you.
Yeah. But main point is no human should be able to see PI within your system. They have to access it. They have to access it through whatever methods you have, and that's the purpose of this. Is saying, all right, get out the database, or even if you do get in the database, it's worthless to you.
Cool. Well, I just want to be thoughtful about time. It is 2:32. If you all have any questions, we'll hang around for a few minutes, so feel free to come up and chat. But thank you all so much for attending our workshop today. We really appreciate your time.
Thank you. We also do have contact info. We have
It's
some
on our deck.
contact info back on the.
I don't know where your tag is.
I don't know where it's at either. We actually don't have contact
Right there.
info. There we are. Yeah, contact info. And also, we Alloy is having a happy hour tonight. For those who are interested, you can pick up one of these cards and RSVP.
We'd love to see you all.
Yeah. Thank y'all. Wow.